Hi, this is Mrs. Ziegler, and I'm going to go through your distance and displacement notes where you will use this video to complete your fill-in notes. You are responsible for this information. So what is motion? Motion is any change in position, okay, of an object. So when we have an object and it's changing position, it is to be in motion. So what is needed to describe motion? Well, in your reading, you should have found frame of reference and relative motion. So in order to describe motion, the frame of reference is a reference point in which motion or the lack of motion is compared to, whereas relative motion is the movement or change in position in relation to the reference point. So the examples that are given is if you're thinking in terms of if you have a train and you're sitting on a train and you see people on the platform. So if you're both not moving, okay, and then the train starts to move, well, you're sitting in the train that is actually moving. When you look outside the window and you see the people on the platform who's also just standing there, as you're moving away from the platform in your train, it looks like to you that the people are moving because of your frame of reference. Whereas the people on the platform, when they're looking at you on the train, as the train is moving away, you are moving with the train, so it looks like you are in motion. So again, it's all based off of the frame of reference. All right, so we're talking about distance and displacement, and how are they different? The definition of distance is the length of the path between 2 points. Remember, it's how far apart something is. Okay, the SI unit for distance is meter. Kilometer, which means it is 1 times 10 to the third meters. Okay, that means it's 1,000 meters, that we use the kilometer as our unit for longer distance. Okay, whereas displacement is the direction and length of a straight line between 2 points. It is always the shortest path between the start and end points. Okay, so it has direction with displacement. So the examples we have here is distance is they move 2 steps. So it's just the path between the movement of the object, whereas displacement is the direction and the path in a straight line between the starting and the end point. So if an object moves 2 steps west, that is its displacement. All right, so here are some examples. So we have the bicyclist that travels 3 kilometers east, then 6 kilometers north, then 2 kilometers west, and 6 kilometers south. So what is the total number, or I'm sorry, what is the total distance traveled? Okay, when we're talking about distance, we're talking about the entire motion of the object. So all we're going to do here is we're going to add up all the numbers. So we will add up 3 kilometers plus 6 kilometers plus 2 kilometers plus 6 kilometers, which will give us 17 kilometers. Now, when we're talking about displacement, we're talking the distance between the starting point and the finishing point. So if you start 3 kilometers east and then you go 6 north and then 2 west and then 6 south, okay, we have to assume that this is just words, but I will show you in class how you will calculate it drawing your picture out. This is something we will practice in class. But if you look here, if we go 6 kilometers north, 6 kilometers south, that means that we haven't really changed our position from start to finish. Okay, but then if we go 3 kilometers east and then 2 kilometers west, that means that I've only have a total displacement of 1 kilometer east. All right, so now, how are we adding displacements? Okay, so a vector is something that has magnitude and direction. Magnitude is a number. Okay, so here you can see that this arrow is a vector because it shows me a direction. And then magnitude is the number. So this is a vector saying that it's 3, we'll say 3 steps east, okay, because it's going in this direction. This is east, okay. This is showing me I take one step south, and again, the arrow showing the direction, and the size of the arrow is the actual amount. Here we see a vector that is 7 steps west. Again, this is the length, which is 7, and the direction, which is what the arrow shows. These arrows are vectors. When we're adding vectors, okay, when they are in a straight line, we add them when they're in the same direction. We subtract them when they're in different directions. So here, So here you can see I have 2 east plus 3 east. So they're all going in the same direction. So I'm going to add them. So that's 5 east. I have 2 east plus 3 west. So that means that my 2 east cancel out 2 west here, but I have 1 more left over. So therefore it adds up to be 1 west. Okay, so here's some practice problems for you. So here I show that I'm going 7 north and then 2 south. So again, they're in different directions, so I'm going to subtract. Then when I subtract, the difference of the direction is whichever one is greater. So therefore, this will be 5 north. If I have 6 east plus 2 west, again, they're opposite directions. So therefore, it's going to be subtracting. And the one that has the bigger number is going to be the direction. So this is going to be 4 east. Since these two are in the same directions, we're going to add them. So therefore, this is going to be 2 west. Okay, now we're going to do more practice problems. All right, so our practice problems. You travel 30 kilometers west of your home and then turn around and start back home after 10 kilometers east. What is your total distance traveled? So we know that we traveled 30 kilometers west and we are starting to go back. So that means we're going to go the back direction, which would be east. After 10 kilometers east, what would our total distance? Well, we would have traveled then, because we're adding up the distance would be 40 kilometers. Then it asks you, what is your total displacement? So again, if I traveled 30 kilometers west and then I've only traveled 10 kilometers east, that means my total displacement will be 20 kilometers west. So if I have a rabbit that hops 10 feet forward, then 10 feet to the right, then 10 feet to the left, and then back 10 feet back, then what is the total distance traveled? So remember, total distance have to do with everything that's traveled. So you're going to add up all of that travel. So 10 feet plus 2 feet plus 2 feet plus another 10, which is 24 feet. Then if I'm moving 10 feet forward, okay, I go 2 feet right and then 2 feet left, meaning I'm coming back, and then I go 10 feet back. That means that from start, I have traveled 0 feet as my total displacement. Okay. All right. Last thing is when we are traveling or when we are calculating distance, or displacement that is not on a straight path, we have to find the resultant vector. What that means is it's the point, a straight line point from start to the ending point, which I will show you in class how we will calculate using a little bit of math. All right, so if you have any questions, please reach out. Please complete your fill-in notes and show Mrs. Ziegler.